In this example, we're going to use trees to solve a conditional probability problem. And I would classify this problem as fun, which means it's can be challenging, but also mostly fun. So I hope you enjoy. All right, we are going to talk about COVID, and I just want to have like a quick little one-way chat here. I want you to think about COVID. I want you to think about all the times that you thought you had COVID, and then when you took a test, and then it would be positive or negative, right? So you might be familiar with the idea of being sure that you have COVID and then your test is negative and you're like, what? Is the test wrong? Am I wrong? What's going on? Or like times that you're like, I feel fine, but you had to test maybe for travel or returning to work or something, and you'd get a positive result and you'd be like, dang, I really didn't suspect that I had it. So this is to do with that. And really, it can apply to any situation. No test is perfect. No test is perfect. There are always chances, hopefully small, for getting wrong results. Wrong results are typically called false positive or false negative. And later in the course, we'll talk about type 1 and type 2 errors, which are the same as false positive, false negative. At the heart of it, a wrong test result is a conditional probability. An accurate test result is a conditional probability. So let's get to the problem. Here, a percentage of the people in a population who have COVID-19 is 32%. Okay, so this is like the real deal, people who actually have it. You might ask, well, how could you know that without testing? And you just have to pretend that a super powerful being from outer space has come down and has like tested people and secretly knows. You don't know, but like they know. Okay, so suspend disbelief. When an individual has COVID-19, a COVID-19 test will give them a negative result 4% of the time. That's that false negative. When an individual does not have COVID-19, a COVID-19 test will give them a positive result 6% of the time. So that's that false positive. Here's the question. Suppose an individual tests positive for COVID-19. Okay, that's the thing that has happened. That is the condition. What is the probability that the person does not have COVID-19? So this is the event in question. So it's the probability of this event, the probability that the person does not have COVID-19, given that the condition happened. So if I were to write it out, I would say probability of not having COVID for real, given that there was a positive test. And we have the definition for this conditional probability, which is a formula, I guess. The probability of this conditional is equal to the probability of not having COVID intersected with having a positive test, divided by the probability of having a positive test. And you may notice that we don't have any of these values given to us in the problem. So on the right-hand side, the way we're going to calculate this, we got nothing. We're going to have to do a lot of work here. We're going to use trees. It's going to be great. Let's go through the beginning part of the problem and see what information is there. First sentence, the percentage of people in a population who have COVID-19 is 32%. Let's write that down. Probability has COVID equals 0.32. And straight away, I can say, what's probability? Someone does not have COVID. That's the complement, 1 minus 0.32, and that's equal to 0.68 or 68%. I'm going to use complements a lot in this problem. I'm not going to write down the 1 minus every time, so just know that that's what I'm doing. I'll say I'm taking the complement. That means I'm taking 1 minus. And when I think about this population, I can automatically split them into two categories. You either have COVID, you're in that 32%, or you don't have COVID, you're in that 68%. Great. Once you suspect you have COVID, a natural next step would be to test yourself. And that's going to be the second branch in this tree. We're going to talk about the test. So when you take a test, you're going to get a positive or a negative. So if you have COVID and you take a test, you're going to get a positive or a negative. If you don't have COVID and you take a test, you can still get positive or negative. So now we have four little spots we can work with. Second sentence. When an individual has COVID-19, so that's that upper branch to start, a COVID-19 test will give them a negative result. So I'm going up, has COVID, but getting a negative result. That's 0.04. I'm going to use the complement here again. If 4% get that negative result, that means 96% would have to get that positive. So 96 are getting, of the people that have COVID, 96% of them are going to get a positive test. Good job, test. That's an accurate test result. 4% of the people with COVID are going to get a negative. Bad test. Stay home anyway. You don't feel good. You have fever, you stay home. Okay, sentence number two. When an individual does not have COVID, a COVID test will give them a positive result 6% of the time. So now I'm going to follow that bottom branch. Doesn't have COVID, but now they're getting a positive result. So that goes here, 0.06. That means the remaining 94% of them got the accurate negative result. And our tree is complete. I'm very excited because I claim that we have all the information we need now to answer this question. So I've moved the tree to the left side and I've just copied the formula from earlier. So our original problem asked, what's the probability that a person does not have COVID given they have a positive test? We said that based on the formula for conditional probability, this is going to be equal to the probability that a person does not have COVID and they get a positive test divided by the probability of getting a positive test. So let's start with the numerator. Probability does not have COVID intersect positive test. We're just going to follow the yellow brick road. That's it. We're going to use our tree. Doesn't have COVID. That means go down first. Positive test, then go up. So here we go. We're following this path right here. Boop, boop, ba-doo. Okay. I'm going to multiply the two numbers on the path. 0.68 times 0.06. That's it. That's the numerator. Halfway done. Let's talk about the denominator. Probability for a positive test. There's actually two ways you can get a positive test. You can have COVID and get a positive test. Good job, test. That's going to be 0.32 times 0.96. I'm just multiplying the numbers on my path. But that's not the only way to get a positive test. You could also not have COVID and get a positive test. Bad test result, wrong test result, but still a positive test result. And in this case, you would be multiplying 0.68 times 0.06. So the probability for getting a positive test is just add these two products. Positive test and has COVID plus positive test and doesn't have COVID. And once you're here, you are golden. You only have arithmetic left. So let's do it. I'm going to multiply. There's three things I'm going to add. Sorry, there are three products. I'll do all three of them at once. In the denominator, I need to add those. And then last thing I do is I just stuff that into my calculator and I'm going to round to the fourth decimal place. Okay, I hope you enjoyed that. I think that's a super fun problem. So in this case, the probability that a person does not have COVID-19, even though they had a positive test, about 12%. All right, good times, good luck, and I'll talk to you soon.